we're going to test and see how much this works. All right, guys. So today what we're going to be covering is we're actually going to be recovering the function stuff that we were supposed to do last Friday. Last Friday was a little bit rushed. Things got a little panicked, and I think it was pretty unclear what we were doing. We're going to go ahead and go through that all again. Hopefully this time it'll make more sense and is a little more prepared. The rest of the videos, since we're not going to have that rushed time in the afternoon where we only have 25 minutes and we have to get through everything, plus we have to wait for everybody to show up. Hopefully this will be a lot easier and a lot clearer. But we're going to go ahead and jump right into it. So we're talking about functions today, as we did last time, and hopefully we can make things a little bit more clear for everybody. So first things first, what is a function? So you've already seen functions in math many times before, but you might not be clear on exactly what they mean. You also might not know them by this name specifically. You've probably seen them as any function as like a y equals something x. It could be y equals 2x plus 2, y equals x squared, y equals ax squared plus bx plus c, sine of x, all those different kinds of things. But a function is an equation that describes a relationship between two variables. And most commonly we use x and y in those, especially if you're graphing. They're always going to be x and y. We can think of our x as our input and y as our output. So if we think of a function as, and if this, we'll talk about this more on the next page. But if we think of a function as kind of a function machine where you put something in and then something pops out. And x is what we're going to put in, and y is what we get popping out. For each unique input, we should only get one output. So for each unique x value that we put into a function, we should only get one y value out of it. So this is what I was talking about, this little thing right here, this diagram. So x is our input in this case. It comes in through our function, which we can think of as f of x, and then out pops our y. So let's say in this case we had x squared, and let's say we use x as 1. We go 1 goes in here, and we get y out. Notice we only get one possible option. Now, interestingly, if we put -1 in, we square that, we also get 1 out. That doesn't make a difference here. That still is a function, but we will also talk about how to check whether something is a function more in a little bit. So the way you've probably seen functions written as is that y equals ax form. And it doesn't have to be just ax, it could be ax squared, ax cubed, whatever. But the point is you see y on one side and then something with x on the other. Y you usually or almost always will see by itself, and x can have whatever variables or numbers or whatever it is attached to it to make the function actually the function you're talking about. Here are some common examples of them. Y equals 2x is a common function, x squared, sine of x, cosine x, 1 over x, natural log of x, any of those things. As long as you've got the y equals and then something with x on the other side. And you'll also notice or remember that you've used different variables in the past. You've probably done like, a equals b or y equals, t squared, and then you used t instead. It doesn't really matter, but in general, we would like to keep it to the y and the x variables just to make things simpler. An equation like this is only a function, or is a function only if there is one unique y for every possible x. So like we said over here, if I could put a number in as my input that would give me 2 outputs, that would not be a function. So for instance, let's look at square root of x. If our function is square root of x and we put in 4, I guess this should be the rule, but if we put in 4 to square root of x, we get 2, but we could also get -2, right? Because -2 squared is still going to be 4. 2 is going to be 2 squared is going to be 4. So in this case, square root of x is actually not a function. And if you graphed square root of x, you would see that it forms a line like this, where the 0 is here. Sorry, those are very unstraight lines. And then we'll talk about the vertical line test actually on the next page, I believe, page after this one. So function notation, this is more of what you're gonna get used to seeing for functions. It will be very useful, and it'll be very clear why we use this in the next lecture. But basically, we use, instead of this y on the left side, we use f of x. So basically, this y in your function literally just gets replaced with f of x. And all that does is tell you that this is a function that is based on the variable x, right? So you can think of this as saying function of x. this is whatever the function is. And again, this could still be 2x, 2x squared, whatever it wants to be, whatever function you have. Again, it'll be more clear why we want to do something like this instead of just using y later. So for example, if we wanted to write y equals 2x squared plus 3 in function notation, all we have to do is replace that y with an f of x. So it just changes to f of x equals 2x squared plus 3. And for now, you can literally just think of them as a replacement. F of x is the same thing as y. As far as you're concerned, for now at least, there's really not a difference. So here's the vertical line test. This is how you can decide whether or not something on a graph is actually a function. In order to decide if you just have a formula and you're asked is this a function or not, you have to test different points. Usually you can test a negative number, a 0, and a positive number. But there are some rare instances where that doesn't work. Oh, it looks like my video froze. Hopefully that's not a huge issue. It's going to look like I'm grabbing my nose for the rest of the video, but I guess that's okay. So when you're doing the vertical line test, as you can see on these, you just draw a vertical line, and if it crosses in 2 points, like it does in these 2 bottom ones, so it crosses here and here, that means you do not have a function, and this one crosses here and here. So these are not functions, but all 3 of these ones are. You'll also see like sine waves at some point. Again, sorry, this is kind of hard to draw on. You'll notice that there's no vertical line here that you can't, or that you would cross 2 points. So this is also a function. Same with tangents, cubes. Basically, most simple functions are going to be, or most simple equations are going to be functions. And you'll note that a horizontal line test does not help. So for instance, this one, if I draw a horizontal line, it'll cross at 2 separate places. That doesn't matter. That doesn't make any difference. Same with this one and this one. But these are all still functions. So it is okay if a horizontal line crosses at 2 points. We're okay with having multiple inputs give the same output. We don't want multiple or one input giving multiple outputs. So one of the easier things, or one of the things that is function notation is easier at identifying is helping you find points on a specific function. So for a given function, you can determine a point on the graph of that function by plugging in any possible x value. So just like you would in like a y equals something x, if you want to say, well, what is the y value when x is 2, you can do the exact same thing for an f of x. So in this case, if we want to plug in 4 for x, if we want to find the point that is at whatever 4 comma whatever, we can just plug 4 into the equation just like you would in a y equals version. So in this case, we do write the x here. It's literally a substitution. So anywhere you see x in this function, you would put in whatever the number you're using is. So in this case, since we're using 4, we put the 4 in here as well. And then the 4 goes here. We solve that out. We get 10. And so we would say that f of 4 in this case, f of 4 equals 10. Right? And so this means that the point resides at 4 comma 10. Another helpful thing about function notation is that it can show you a specific point without needing to know the actual function. So you don't need to know what the function was, what the formula was. You don't need to see a graph of it. You can still figure out a point just by being given something like we see here. So if we see this f of 3 equals negative 9, remember that because this is supposed to be f of x, this is telling you that your x value is 3. So this is your x. And then we're saying the total when you plug in 3 for x into whatever this function was, and we have no idea what that is right here, your y value or your f of x value comes out as 9. And these are the same. And I believe that's all that says. So f of 3 equals negative 9 tells us that when x equals 3, f of x or y, they're the same thing, equals negative 9. And thus we know that a point exists at 3 comma negative 9. Now, this is probably the area that I lost most of you last week, domain and range. So first of all, I talked to some of the other math teachers and found out that you guys have only learned how to do domain and range written as equations and inequalities. And second of all, I was giving you the wrong information for like a solid 2/3 of the day yesterday on Friday. So this time we have it 100% clear. I promise it will hopefully be easier this time around. But let's start with the definitions of those. So every function and its graph have a domain and a range. The domain represents every possible value of x within the function. The range represents every possible value of y. So one of the ones I was showing you last week, 1 over x, we know that x can't equal 0, otherwise that function is undefined. So whatever the domain is, x can't be 0. For y, in this case, it can't be, no, in this case, it can be anything. Like if we do sine of x, though, for instance, y can never be greater than 1 or less than -1. So that's an example of where your range is going to be contained. So you've probably seen domains and ranges written as inequalities. This is the way that I was told you guys were taught this in Algebra 1 and 2. So if you see something like x is greater than 3, you'll notice it's a capital X. This is because it's saying that all the x values, not just one specific individual one. But it says x is greater than 3 is an option, or -10 is less than y, which is less than or equal to 23, right? So this is telling you that y is in between 23 and -10. So the way that we're learning how to write domains and ranges is called interval notation. And interval notation basically writes out, instead of writing inequalities, it writes out a notation that's a little simpler to read, a little bit faster, and it looks more like points. So basically this just tells you all of the possible points on a graph in a slightly easier way to write it out. Now, I made it significantly more complicated on Friday. Hopefully this time around, we're going to make it a little bit easier for you. So interval notation is pretty much the same thing as writing points on the graph, but there are two different types of brackets that we use, and those are normal parentheses and square brackets. Normal parentheses represent a number that is not included in the domain or range. So if you were thinking of it like this, that would be a greater than, right? So if x is greater than 0, 0 is not included, right? Because it's not greater than or equal to. By contrast, the square brackets represent a number that is included in the domain or range. So a square bracket basically is like x is greater than or equal to 0, right? So this equal to means it can be 0, so 0 is included. So when we would write this out, we would have the 0 in a square bracket. In this one, since it's greater than 0, it can't actually equal 0, so we would use this parentheses to denote that 0 is not included in the function. So this really quick, we're going to do some practice with interval notation. We're going to try writing the following domains and ranges in interval notation. So one of the things that you'll need to know for these is that you use negative infinity and positive infinity when something is going all the way to one of those two values. So in this case, x is greater than 4. So since it is exclusive, 4 is not included, we're going to use a normal parentheses, and because this means that the function or the number is not included in the function. So x, we've got 4 on this side, and then it goes all the way until positive infinity, right? And x is any number greater than 4. So you get a positive infinity. And when we're writing these, we never actually include the infinities because infinity doesn't technically mathematically exist, right? You can always have a bigger number. So it is also going to be a normal parentheses, not a closed bracket. Now, in this case, we say y is less than or equal to -3. So that means that the lowest, the minimum possible value is negative infinity, right? It'll go on as low as you can possibly go. And then the highest value is -3. Now, in this case, because we've got this equal to, it is being included. Y can equal -3. So we want to use a square bracket instead of a parentheses. For the last one, we've got x is greater than 3, but less than or equal to 9. So the smallest possible value of x is 3. And the greatest possible value of x is 9. 3 is a greater than symbol, or less than symbol, depending on which way you're looking at it. So that means 3 is not included. 3 cannot actually be a value of x. So we're going to use the normal parentheses. And then that's a normal rounded one. And then 9 is included. So x can equal 9. So we need to use a square bracket for that one. And that's how you'd write that. Last thing with interval notations that we need to know is something called union symbols. So basically, when you have a domain or range that consists of two separate points or two separate ranges of data, you're going to be using union symbols. So something like this, when it says x is either less than 2 or greater than 10, right? So if we had this on a number line, like this, right, and let's say 2 was here and 10 was here, and there'd be numbers in between, but we don't really care about those right now. We would have x could be any point over this way, and x could be any point over this way. These are two completely separate ranges of data. You can't write them together all at once. So the way that we do this is we're going to write the two separate intervals and then combine them with what's called a union symbol. And a union symbol looks like this. It's basically just a U. Technically, it's supposed to be a little bit more like rounded at the top. So it's almost more like a upside down or a parabola, but it's basically a U. And in this case, we would do negative infinity to 2. You'll notice that this is a rounded parentheses because the 2 is less than, so it's not included. We've got the u, which says that these are together. And then we've got 10 all the way up to infinity because x is greater than 10. So a couple quick practices with these ones. We've got y is less than negative 4. So it can go all the way to negative infinity. We know that, which is not going to be included. And then it is up to negative 4. And since we don't have an equal to here on this less than, we know that negative 4 is not included, so we're going to use a normal parentheses, whatever. And then we have a union symbol right here. It's kind of ugly, but that's okay. And then we've got negative 2, oops, and that's actually going to be a square bracket because it is greater than or equal to. Square bracket, negative 2, and that goes all the way to positive infinity. And that is going to be a normal parenthesis, parenthetical. I don't know. I should probably figure that word out. That's okay. All right. In this case, we've got x is greater than or equal to 3 and less than 5. So this one, we've got 3 on the bottom. We've got 5 on the top. 3 is included, so we want a square bracket. And 5 is not included, so we want a normal parentheses. And then I guess this is y equals. You could also do domain equals range equals. It doesn't really matter. And then here we've got x is less than 2 or negative 2, or x is greater than or equal to 4 and less than 6, or x is greater than or equal to 10. So in this case, there are 3 separate data points. And if we wanted, we could write them out on a number line as well. We could go like this. We could say, all right, here's negative 2, here's positive 4, here's positive 6, and here's positive 10. We're saying x is greater than or equal to 10, so it's there. It is less than 6 and greater than or equal to 4, and it is less than negative 2. So we've got 3 separate data sets here. Each one is going to be combined by a union symbol. So to start, x goes all the way to negative infinity. Negative infinity. It's going to be a normal parentheses, comma, goes up to negative 2. Negative 2 is not included, so we would use another parentheses again. Got our little union symbol right here. And then we've got 4 to 6 for our middle set. The 4 is included, so we want a square bracket on that. The 6 is not included, so we want our normal parentheses. And then another one, oops, that one's even worse. And it is from 10 to positive infinity. Positive infinity has that parentheses, and then 10, since it's greater than or equal to, is a square bracket. So hopefully that clears everything up. I'm going to add a second video to this as well to help with interval notation so you don't just have to rely on me. But that is it for the lesson today. We're going to, basically you have the same homework assignment that you did on Friday. If you have done it already, you don't need to redo it, but maybe check through the parts that this helped clarify, if it helped clarify anything. And then those of you that didn't finish it, hopefully you'll actually have the information to do it correctly this time around. But I'm not going to make you guys redo the whole assignment or anything like that. So if you've already done it, you're good to go. I would strongly recommend still making sure that you know how to do these correctly. I'm not going to dock you points or anything if you turned it in beforehand, because it was definitely my fault. Right? And then otherwise, we'll get into functions further tomorrow. So I will see you guys then.